I want to summarize the talks a bit, and then we can pass to some questions. We already have some questions in the chat. We started with Professor Papadrakakis, and I feel really lucky today to get an overview of the trends in computational mechanics. Then Professor Papadopoulos presented some data-driven computational mechanics techniques at exascale, and he presented to us surrogate models for modeling the constitutive laws, and also how AI can help nonlinear solvers. Afterwards, Professor Markou presented to us another aspect of AI, how we can use AI to simulate, to do similar things like simulations, like what do. Then I presented how we can distribute this training across many GPUs, and finally we had some hands-on, really interesting hands-on examples. As I said, we had some questions in the chat, and I endorse you to discuss further here. Also, I would like to mention that the computer codes I presented and also Professor Markou are online available. The multiprocessing, I will soon send code in our GitHub channel.
And of course, for those that would like to collaborate or work under our guidance, we have done, and Dr. Nikos Bakas, an extremely impressive work in order to reach to this point. And now we can actually undertake, we already have like 10 students that are working on AI, but there is always room for more, especially PhDs. So we are definitely open to new collaborations. As you've seen, you don't need to have extremely deep knowledge in AI and machine learning in order to be able to get involved. Even though we have the ability through the collaboration with Dr. Nikos Bakas to take you until the end in terms of depth and even programming and improving existing methodologies, or even creating your own machine learning, artificial intelligence method and algorithm.
Thank you, George. I shared also my mail in the chat. You can ask here for more for codes and questions, and we can discuss now. We still have some people. It was a wide event. It was nice to have a lot of people here, but feel free to ask any question. You can unmute yourself and tell us your questions or thoughts.
By the way, don't feel intimidated. Some subjects definitely were extremely complicated and deep, but even general questions, there are no stupid questions, so only stupid answers is what they say to our students. But yeah, sometimes some people do tend to break the rule. But please feel free to ask anything you like. Maybe if you would like me to show something additional. By the way, to see how easy it is to start working with something new, or a new data set here. Let's see if I change this to 2, right? Control save, come back here and go back to the data sets, create a new folder, folder number 2, add the reinforced concrete column experimental results here. Then again, we can run, let's run this, let's say up to the first machine learning, including the polynomial rep. and then you will get your new results within the folder. And by the way, this is a data set which consists, let me open it for you. I also have the publication, very important announcement as well. You are more than welcome to join us at our mini symposium at Computational Dynamics Comdin 2023 conference that is organized by Professor Manolis Papadragakis. And we have a mini symposium there where we will be presenting also the results on developing predictive models on the shear strength of reinforced concrete columns. And this is the corresponding, in this case, data set that we used that resulted from actual experiments around the world. So this was done in coordination with Dr. Anthos at the Neapolis University. And as you can see here, we were able to get a correlation factor of 0.8296, while the best current correlation factor was 0.65. So this is a huge improvement. And what's amazing about it is that the actual data set consists of less than 80 data samples, 80 results. And by the way, now I just perform in front of you the training and development of linear regression and nonlinear regression, and the results are ready. Like, this is how easy it is and how efficient it is. I'll come here to the nonlinear regression and open the mean average error. Okay, and if I go to, this is the testing and this is the training, and it's done. Definitely developing data sets, finding reliable data sets is not an easy task. It's extremely time consuming, and the way that we are working now in our research group and the research team, the developing data sets is like almost 90% of the work, which is very, very tedious. And in order for us to be able to replace the finite element analysis with the finite element method, which was a big statement, we will need millions and millions of results from different types of models. And who knows, maybe one day we will achieve our final goal with Nikos, which is to create a ChatGPT for structures. And nobody will need to perform a finite element analysis again.
To predict everything without analysis.
Bravo, exactly. No need for all the thousands and thousands and tens of thousands of euros and US dollars spent on electricity just to run those supercomputers, which is definitely one of the biggest issues and disadvantages when we use machines like that. Just to keep them cool, I mean, you need a lot of power and electricity, and we know it doesn't come cheap.
We have a question from Antonis Parasiris.
Hello, can you hear me?
Hi, Adonis. Yes.
Hello, Nikos. Hello, Professor Markou. Very nice tool and presentation. Thank you very much.
Thank you, Anthony.
I see in the chat many are asking for the GitHub link or something, the code to be available. If you could, you said it's in your personal GitHub page.
Yes, I will share now the GitHub. It is without the multiprocessing.
May I ask?
For the multiprocessing, I will share it in the next, because it is very...
It's new.
It's new. What Professor Markou presented, we already have it on our GitHub. Just a moment to share the link. And please send me your email to share with you send to the entire list.
And the corresponding, of course, publications where you will be able to
or
read
send me an
more.
email. Adoni, send me an email to send you the link for the new.
Right.
In the next days. Yes.
Do you plan in the future to add convolutional neural nets on that, or just the the ones that you
We
have.
have followed a very generic approach. We can add any method we like very easily. We use PyTorch for a neural network, so with we can add convolutional in
And
less, because we change simply the function, the method, the Python method defining the structure of the network, and all the same. This is a very generic. I can share my screen to present more specifically. Just a minute.
No, I was wondering because in the example you had already the most important features that you had, but if you have like an image, then you need to extract the useful features first. So that could be another thing that
yes.
in the tool.
Okay, this is different. Yes, now the program is developed for tabular data sets. To be able to analyze and predict images, this can be done. It needs more modifications, but okay, perhaps you would be more interested for the tuning part, for the hyperparameter tuning. It depends. Look, if you have images, probably you will have some hundreds of thousands of images to create a robust, or except if you use a pre-trained model.
And of course, Nico, we need to say here that this is just the first version of the code, and therefore this is a first step to open up doors for future collaboration. And more is coming definitely in the near future, including maybe an environment which will help the user even more to use the algorithms through Windows-based applications. So we'll see. There's a lot of work to be done, and yeah, we are very excited for sure. We already started collaborating with colleagues in the geotechnical engineering, probabilistic, and people in the African continent, Europe. There is a lot of interest for sure, and we are open for new collaborations and especially proposals in order to get bigger funding, given the fact that this is our #1 goal now.
Okay. Do you mind if I follow up with another question?
No, of course.
The finite element that you said earlier.
Yes.
You said that the experimental data often have errors, but so do the finite element simulations, and they
definitely
are dependent on the discretization of the polynomials used. So have you done sensitivity analysis on if you downscale or upscale, if that affects the machine learning model then?
Definitely, it's a great question. This is the Pavlos Kyklos that we said, that we say in Greek. We use experiments in order to validate our models, and now the experimentalists use finite elements to validate that their experiment makes sense. And one might ask, who's correct? What I can guarantee you is that when you use a 3D detail model and the models that we've developed that are found in Recon and PEA, and you solve the same model, which is the same, perform the same experiment, and in this case, numerical experiment, for 1 million times, you will get the same result. If you do that through experiments, definitely you will not be able to get the same results, even if you perform the same experiment 1 million times. It will always be different. So this is #1. #2, we did a lot of work in sensitivity analysis on the results, and this is what I actually mentioned before in terms of the reinforced concrete beams without stirrups, which was one of the first works that we published with Nikos. And in this case, we generated a data set just through nonlinear analysis, nothing else. We got the ML and AI software, the algorithms we trained, we created predictive models, and then we used actual experiments in order to see if we have the ability to predict those results. And this is where the comment came from. Actually, we got an ACI data set, and it had hundreds of results on 3-point bending tests. And we had cases where they had the exact same specimen with the same specification, geometry, material properties in the same laboratory, and the differences between them were for 15%. I also I participated in a prediction competition for steel fiber reinforced concrete steel fiber reinforced beams, T-beams, eccentrically, not eccentrically, but asymmetrically loaded without stirrups. And in that case, they had two specimens, and their difference was like 15% between the exact same identical specimens that they were performed and then tested the exact same day live, right? And we got the third best prediction in terms of maximum load, and the first best prediction in terms of maximum strain. And I didn't even develop a steel fiber reinforced concrete model. I just used the concrete one by giving it some tensile strength, additional tensile strength. So we did a lot of work there, but it doesn't mean we can claim it's game over. There are new material used. We do a lot of work in retrofitting as well, but there's a lot of work to be done, and not only push over and monotonically, but also in the cyclic manner, and a lot of work in soil structure interaction, non-linear dynamic analysis by taking into consideration soil structure interaction phenomenon, non-linearities in the soil and in the superstructure in a detailed manner. And there are many challenges over there as well. Diego Suarez, yes, what's your I hope I covered you. Thank you, Adonis, for the interesting questions.
Thank you very much.
Thank you so much. Diego?
Thank you for the presentation. Can you hear me?
Yes, loud and clear.
Perfect. It's more like a comment rather than a question, let's say. But
Yes.
from what I see, it's very important to identify a particular input for which to train the models on, right?
Bravo, very correct. Yes.
My question is, in your experience, you pick those inputs, let's say by engineering judgment, and then you train the model and see, and then eliminate the ones that you don't need.
Exactly, and you have the ability to do that, and we've seen how it's super easy given the fact that we have the ability to, let's go to the first folder where we performed everything, all the results. And if you go here and go to all sensitivity, you will be able to see which parameter is important. Let's say I want to create the smallest, like Dr. Anthos at the Naples University. He was a PhD student and then became that, and he was working with his supervisor, and he said, I want a small equation. I want an equation with only 3 parts. So you'll say, okay, what will I cut? In this case, if I want to use only 3 parts, I'll say, all right, I will remove definitely the Young modulus of elasticity of the soil, the depth of the soil, and maybe leave only these 4, or even the width. I will just allow L, rho, and H. I know that these are the most important, 3 most important input features. I will keep them, execute the analysis again by updating the dataset, removing the 3 input features and allowing only 3 input features in the dataset, get the new error metrics, and then decide on whether that is acceptable or not. Now, we all know that the fundamental period, according to international design codes, use a single parameter, just the height of the building, which of course makes it impossible to get a correct value. And that's why these models that we propose were the most advanced currently in the international literature. But there is a lot of many colleagues, especially the ones that are older than us, they don't understand the methodology, and they say, there is no mathematical background behind it. But at the end of the day, it works, right? And if it works, and not only civil engineering, in any part now of life, like you have chatbots and ChatGPT, which actually can get knowledge, combine it, and give you something new, right? So it's not just numbers that we are looking at here as engineers, but pretty much anything, face recognition, driving a car, allocating, finding a ripe tomato, which was in Descartes 2022, they were developing algorithms to choose tomatoes, and the robotic hand was taking a tomato from the plant.
Also, George, if I may add to Diego's question, apart this, the sensitivity which ranks the features by importance, we also do two more things. The first is an initial feature selection in terms of multicollinearity. We automatically remove features that are collinear from the dataset. So if, for example, column 3 is a linear combination of column 4 and 5 and 1, this is automatically detected and excluded. Furthermore, what Professor Markou presented before about the polynomial regression, this is an automatic, let's say, feature engineering, because we try many non-linear combinations, multiplications.
You see here, 21, 23, 22, yes. 25. This is automatically selected, and these are the number of this is the number of the features of the final equation. So now the final equation is this one. It's rather longish, another issue that we faced with reviewers. And it has 25 features. And we say the future is not an equation. The future is a model that we won't be able to see, right? And if that predictive model is a black box and it has 100 times better accuracy than a very simple equation that was generated through semi-empirical methodologies, then the scientific community eventually will have to accept it, right? Can you see the model of ChatGPT? I bet though we all use it when we want to write a paragraph or just to have a starting point, let's say, of introducing something or thanking somebody or whatever. I don't need to see the model to read and say, oh my God, that works. It's really nice. I take it and then I change it, modify it, paraphrase it, and I have a starting point. And at the end of the day, I have results. So we as civil engineers and a lot of engineers that are used to using formulae, the Hooke's law, stress equals to epsilon multiplied by capital E, which is strain and Young modulus, right? I know how it works. This is the line. This is what it means. So imagine if somebody sees this equation here, and they say, oh my God, they're getting lost. And then you say, all right, if you understand the methodology and you understand how it works, you'll go back here, right? And you go to the sensitivity, and then you'll understand exactly what each and every input feature does within that equation. This is an advanced sensitivity analysis for all the input features found within the predictive model that was automatically generated by the polynomial regression with high parameter tuning. So this is the width B of the building, the depth of the soil, the Young modulus of the soil, which is the flexibility of the soil at the foundation level, the height and of the building, and the length of the building along the direction of oscillation, because this derives and results from modal analysis. I hope we covered you.
Very interesting. Yeah, thank you. So for the input, I would like to, is it ideal to have independent variables, or is it better to combine, like the professor was saying, to have variables that are dependent, like let's say the aspect ratio of the building, something like that?
You can try different approaches, and sometimes in the recent work that we just sent with Dr. Nikos Bakas and Ashley, our master student, now on the 100,000 fundamental period of steel structures, including soil structure interaction. We even tried using logarithmic expressions of calculating, let's say, the ln of an input file and adding a new column. So you can use different combinations in order to improve the input features and get better models, which will be extremely long, but way more accurate than the ones that they use a limited number of features. So this is something that requires investigation, and definitely it's something that applies. And what you said before, choosing the input features and using different combinations of those features might lead to a more accurate predictive model.
very interesting. Thank you very much.
Okay, Nico, do you see any other hands? I don't see anyone that would like to ask. So Nico, the floor is yours. You can thank everybody from my
Okay.
side. Thank you so much, and enjoy the rest of your day. Thank you.
Thank you very much, George, for the presentations and the questions and all the enthusiasm for presenting the very interesting codes and results. Thank you all for participating. I would like to thank once again our presenters, our distinguished presenters, Professor Papadrakakis, Professor Papadopoulos, and Professor Markou. As I said, this is a EuroCC event. We are available to discuss further. You can send us email. We can discuss on computer codes, on access to big supercomputers in Europe, and related things. And thank you all for participating in these events. More events will follow, and we will inform you accordingly. Thanks a lot.